continuing on from our last video. In this video, Steve's going to begin coding up our render script. Now, in doing this, we're going to jump back and forth between the script itself and the whiteboard, just making sure everybody has a good mental picture of what's going on. So the coding process will begin back in that tool that Steve had added to his custom shelf a few minutes ago. So Steve, let's go ahead and jump back into the tool.
So I'm going to right click on our tool and come down to Edit Tool, and over on the Script tab for the tool, and let's resize this so we have a little bit more room to work in. We're going to start entering code into our tool.
Okay, so starting out, first thing, a class.
Yep, we're going to be creating a class, and all will be revealed as to the importance of this class in just a second. And this class is going to act as a container for some information, and that information is going to be our render information. So I'm going to create a class called render info, open parentheses, close parentheses, and then the colon to end the start of the class definition. We're going to tab in so that we're indented, and I'm going to create an initialization function. As we saw with our primer into Python, we can create an initialization function which acts as a constructor. When the class is instantiated, the constructor will be called
automatically.
Exactly. So I'm going to create a def underscore underscore init underscore underscore, and I'm going to pass self, if I spell that correctly, self through to this constructor.
And again, this constructor name, this is a very specific name, so we are following a convention set forth by the creators of Python here. And again, as Steve is coding this class serves as a template or a blueprint for objects. Now, when an object is actually created from this blueprint, this constructor is going to get called automatically, and that gives us the ability to set some stuff up ahead of time.
So what are we going to store within this class? Well, I'm going to quickly jump over to the whiteboard and take a look at some of the things we were doing when we called our description. So we got our description file and we said new render, and then we're saving things like objects, oname, lights, lname, and pass. Well, what if we were to take each of these and store them in the class, and then we'll come back and talk about exactly why we're doing that. But just keep in mind that we're storing all of our render-specific information, so all of the information we need to execute a single render into this render info class. So that's going to be our objects, our oname, our lights, our lname, and our pass. So I'm going to jump inside, tab inside twice so that we're inside our function definition, and I'm going to say that, okay, self has a .omember, and that omember is going to be for our objects. And I'm going to initialize that to star, which you recall is the default for the candidate objects on our render node. I'm going to say that self has a .l, that's going to be for our lights. Again, I'm going to initiate that to star. Self.p is going to store what pass type we're rendering. I'm simply going to initiate that to nothing. And I do want to use single quotes for these strings. Just getting picky. So yeah, we'll use single quotes for the strings. So I'm going to initiate this to nothing, and that means that we are going to need to make sure that when we're creating definitions of renders, we specify a pass name. If we don't specify a pass name, this guy will never get filled, and our script will tell us that we haven't specified a pass when we go to render. We're also going to store our object name, which you recall is our nickname for our objects, defaulting that to nothing. And finally, we're going to store our light name, which is our nickname for our lights, defaulting that to nothing. So I'm going to enter to come down, and now that is going to complete our class definition. So why are we storing these 5 pieces of information into a class? Well, let's jump back over to Photoshop, and let's talk a minute about the approach that we're taking with our script. Now, when we executed through this description file manually, we talked about saying that we're having a new render, and then creating, specifying our objects, the nickname for the objects, the lights, nickname for the lights, and then a pass, and then firing off that render, and then going on to the next description. But this isn't technically what we're doing, and when we did execute through, I did mention that it's going to be slightly different when we actually have our script. What we're going to do in our script is we're going to, when we hit a new render command, we're going to create a new instance of our class. So let's find some whiteboard space down here, and we can create a new instance of our class. So let's draw our template for that class over here on the left hand side. So we've got our class that was called render info, and inside render info we had O, we had L, we had P, we had ON, and we had LN. And we can think of these as boxes in which we can store information. So when we hit the new render command within our description file, our script is going to go ahead and create a new instance of this class. So it's going to take this guy and he's going to create an instance of him. So let's create an instance. Keep this fairly small because we're going to need a couple of these guys. So we're going to have an empty instance of this class with our O, L, P, O, N, and LN, and you'll recall that we defaulted O to star, we defaulted L to star, and everything else to an empty string. So we're going to have this instance of our render info class. Then what's going to happen is as we parse through our script, whenever we hit an objects command, we're going to take the argument that's been passed to objects and store that into the O member of whichever the last instantiated class of render info was. So we're going to take our O member, and that's now going to be set to, in this case, stadium import. So stadium import. When we hit the O name command, we're going to override our ON on whatever our latest instance of this class happens to be, so ON, and in this case we're going to override that with stadium. So that's going to become stadium. And we're going to do the same for lights, for LName, and for pass. So lights will become bleachers top, LName will become bleachers top, and pass is diffuse. So lights will become bleachers top. LName is going to also become bleachers top. And we said that our pass was equal to diffuse. So what we're doing by calling these commands in our description file is not technically setting up the render just yet. We're kind of storing them. We're saving them into an instance of this render info class so that we can get back to them later. Well, why are we doing this? Well, actually, let's finish parsing through the file first and then go on to.
So we just came down and we hit a new render.
We've hit new render. And when we hit new render, we're going to get another instance of this guy stacked on top of our existing instance. So we can say that this is guy 0 if we're 0 based, and now this is guy number 1. So we've got another instance of this class that will come in with O, L, P, O, N, and LN, and of course default value of star, star, and empty strings for these guys. And then we repeat the process, so we hit an objects command. When we hit an objects command, we're going to set the O member of whichever the last instantiated class was. Well, that's now this guy. It's not this guy anymore because we've now created him afterwards. So we're going to set the O member to whatever we have as our argument to the objects command. So that's going to be stadium import. The same again when we hit OName, we're going to set the ON parameter member of our class to whatever we have as our argument, in this case stadium. When we hit light, we're going to set the L member of our class equal to the argument to that command, which is bleachers bounce. When we hit LName, we're going to set the LN member of the class equal to the argument to LName, so bleachers bounce. And finally, when we hit pass, we're going to set the P parameter to the latest instance of our render info to whatever the argument to pass was, which is going to be diffuse. So now you can see as we came through our description file, we hit new render. We created a new instance of our render info class. We then called various commands that are going to start filling in the information in that instance. As soon as we hit another call to new render, we create a new instance of this class and repeat the process filling in the information. This is to mean that if we were to call the objects command more than once, but we've only called new render once, so say we called objects again in here, it would simply override the value that was in here. We wouldn't create a new render, we'd simply override the value. It doesn't matter how many times we call these 5 commands after we called new render.
Let me give you an arrow.
Thank you. So it doesn't matter how many times we call these 5 commands after calling new render, whatever we pass to them, the last time we call them is going to be what's saved in that instance. So that's worth keeping in mind. It's also going to make life a lot easier in terms of firing off renders, because we don't have to say, okay, I've defined the render, now go away and render it. Now I want to do a new render, go away and render it. We simply say, I'm starting a new render description, fill in my data. I'm starting another new render description, fill in more data. So we can keep parsing all the way through the file, building up and stacking up render descriptions, and then go away and render them later. And it's an extremely important reason why I've chosen to go with this approach. And that comes back to something we demonstrated in the previous video, and I intentionally left one element of that out. So let's jump back over to Houdini and talk a little bit further about file input output. So I'm going to accept our tool and come back over to our example here. And we were dealing with file input output, and you may recall that we opened up our example.txt document. Well, let's say I want to delete this file off my disk. Cannot delete example. It's being used by another person or program. Well, why is that? That's because we've opened example.txt using Python in Houdini. So we now have access to that file. We can read from that file. We haven't told Python to close that file. We still have the file open, which means that we can't get access to it anywhere else in the operating system. That file is open and it's assigned to us. And it's very bad practice to have a file open any longer than you really need it to be. To close a file, we can simply call our fobject close method. That will close the file. So now we can actually print out fobj, and it will tell us that it's a closed file. And if we come back over and want to delete out example.txt, we can now delete it out because we don't have access to it in Python anymore. So why is this important in terms of our render script? Well, we're opening a description file to parse through it and read in line by line and react accordingly. Now, if we were to come down and be reading in our file and hit our first render description, read in the 5 commands that define that render, and then go away and render, that render could take 10, 15, 20 minutes. It could take hours.
It could crash.
It could crash, and our file would still be open. And I really wanted to avoid that at all costs, because then we'd hit the next render, and we'd be rendering out, and the file would still be open. And these description files, we may take 10, 15 minutes to write up our description file with all our passes and be really happy with it, and we don't want to worry about having that file able to be damaged in any way because it's open for so long when we're rendering. So instead of reading in the file and rendering as we're reading in, I decided to take the approach that we're going to parse through the file, and we're going to cache, effectively, all of our render information and stack it up in an array of these render info classes so that we can quickly parse through our file, and all we're doing is saying, okay, take Stadium import and put it into a member, take Stadium, put it into a member. So all we're doing is reading in and assigning data into memory. Everything's getting stored in memory. We can then get to the end of our file, and when we get to the end of the file, we can close off our file. So now our file is not open on disk anymore. Other programs can access it. We can't risk damaging it if we were to crash when we're rendering. So our file is no longer open, but all of the data that we needed from our file is now stored in memory. So we're going to have this array of render info that we can now loop through the array and say, okay, take the first entry into the array. Now we can still go ahead and say, okay, set the render node to have these objects, set the render node to use these lights, set up my lights to use a diffuse pass, build my file name based on the fact that we've got an object name of Stadium and a light name of Bleachers Top, and now go away and render. We can then jump to the next item in this array and do the same. We can set our objects, set our lights, set up our lights ready for a diffuse pass, build our file name based on object name and light name, and go away and render. And it doesn't matter how many of these descriptions we put in the description file, we'll simply have them all stored in an array that we can then iterate through and execute these one at a time. But our file is now closed, so we're now rendering, but the file is not open when we're rendering. And that was the reason for taking this approach. It also makes things easier in terms of the description file, because we simply have one command for dealing with setting up a new render. We call new render, and when we do that, it's going to instance a new render info class. Any commands that then deal with objects, object name, light name, and pass will simply work with whichever our latest instance of this class was, up until the point where we call new render again. When we call new render again, we get a new instance and the whole process repeats. So it meant we had a single command for creating new renders, as opposed to having to create a new render and then maybe have a command that told it to execute that render after we've set it up. So with that, that's an overview of the overall
Overall functionality.
yeah, the
of
overall
the script
algorithm we're taking,
and how it's going to be using this class.
and also we took the time to implement that class that we're going to be using. And with that, that's going to conclude this video. Thanks a lot.